Welcome to this video to help you out with your homework. This video is about developing the model of the atom. Now, all of this started with a Greek scientist called Democritus in around about the 5th century BC. He thought that all matter, whatever it was made of identical lumps called atomus. Atomus was a word in Greek that meant indivisible. And really, this is as far as we got until the 1800s. In 1804, John Dalton agreed with Democritus that things were made up of tiny spheres that were called atoms and that they couldn't be broken up. But he thought that each element was made up of a different type of atom. Nearly 100 years later, J.J. Thomson discovered particles called electrons, and he found out that these could be removed from the atoms. So Dalton's theory wasn't quite right, and Thomson suggested that actually atoms were spheres of positive charge with tiny negative electrons that were stuck in them, a bit like the fruit in a plum pudding, which is why it's called the plum pudding model. In 1909, however, scientists in Rutherford's lab tried firing a beam of alpha particles at a sheet of gold foil. This was called the alpha scattering experiment. From the plum pudding model, they thought that all of the particles would pass straight through the gold sheet or only be slightly deflected. And although most of the particles did go straight through, a few of them were deflected more than they expected, and some were actually deflecting right back, bounced right back out them, which was something the plum pudding model couldn't explain. Because a few of the alpha particles were deflected back, the scientists reasoned that there must be a concentrated mass in the center of the sphere, which was the nucleus. This nucleus must also have a positive charge because it repelled the positive alpha particles. Positive and positive repelled. They also realized that because a lot of the particles did pass straight through, that actually the atom must be mostly empty space. And this is where we sort of developed the first nuclear model of the atom. The nuclear model that resulted from the alpha particle scattering experiment was a positively charged nucleus, and that was surrounded by a cloud of negative electrons. The next scientist, Niels Bohr, said that he thought electrons orbited the nucleus, but they did it at certain distances away from the nucleus, which he called energy levels. He had theoretical calculations, and he also collected experimental data, and these both agreed. Evidence from further experiments changed the model that we had before to show a nucleus that was made up of a group of particles which are called protons, which had the same positive charge, and that added up to the overall charge of the nucleus. About 20 years after this, though, the nucleus idea had been accepted. So in 1932, another scientist, James Chadwick, proved the existence of the neutron. And this was really important because it explained the imbalance between the atomic and the mass numbers that some elements had. This is our current model of the atom. It shows that the nucleus is tiny, but it makes up most of the mass of the atom. It contains protons and neutrons, and because protons are positive but neutrons are neutral, this does give the nucleus an overall positive charge. The radius of the nucleus is about 10,000 times smaller than the radius of the atom. The rest of the atom is mostly empty space, but the negative electrons whiz around the outside of the nucleus really fast. They give the atom its overall size. The radius of an atom is about 1 × 10⁻⁻10 meters. If we compare these particles, we can see protons have a positive charge, electrons have a negative charge. There are usually the same number of protons and electrons, which is why overall an atom has a neutral charge. Electrons do have the ability to move energy levels if they gain electromagnetic radiation, or if they absorb electromagnetic radiation, they can move to a higher energy level, which is further from the nucleus. If they release electromagnetic radiation, they will move to a lower energy level that's closer to the nucleus. If one or more outer electrons leaves the atom becomes positively charged. It becomes a positively charged ion. We're currently pretty happy with this model that we have, but there's no guarantee that it won't change. As experimental data comes in, more experiments come in, we may need to get rid of our current model and we may need to change it. Here are some facts that you may like to write down on a flashcard. These kind of summarize the points from the video. And this video also came along with a 6-mark question. So I've just given you a suggestion of one of the techniques we use in class, which will help you to answer the 6-mark question. So it wants you to compare. That means look at similarities and differences between the plum pudding model and the nuclear model of the atom. So to do this, you look first of all at similarities, things they have in common. For example, both models contain electrons. A difference, though, would be that the plum pudding model had the electrons in the center, whereas the nuclear model had the electrons around the outside. So if you sketch up a little table like this before you try and answer the question, it's really going to help you maximize your mark. And then just to finish off, there are 5 more facts here for you to write onto your flashcards about the structure of the atom, the modern structure of the atom that we have now. So we've got the history of the atom, but also the modern structure. So I look forward to reading your 6-mark answers on Friday.